Hi, welcome to my channel. This is Defender, and today we're going to be deep diving into how to tighten and secure SSH server, right? With a key-based authentication and disable password-based authentication, right? So in this scenario, I'm going to play the attacker, which is on my left side, running on Ubuntu, and then I'm going to be also an admin user, right here on the right, running on Ubuntu, right? Both virtual machines. So essentially what we're going to do is, for the attacker, we're going to identify what is the IP address, ports available on a network that we just broke into, right? And after conducting such attack on our SSH server, that's when I'm going to show you guys how to mitigate this attack and lower or decrease our chances of, I would say, a potential attack on our SSH server, right? So let's get straight to it. So first, again, as the attacker, I don't know what the IP address, I don't know anything, right? So the first thing I'm going to do is I'm going to use a tool called Nmap, which is a network mapper, be able to identify IP addresses, ports, and even potential vulnerabilities associated with those ports, depending on what service number or service version is being ran on those ports, right? So, but I'm just going to do a simple nmap scan. We're going to do sudo, basically saying, hey, I need higher privileges to conduct such task nmap. And the first thing we're going to do is we're going to do a list scan, scan the entire network to identify any end hosts, right? So let's scan. This is going to be just a simple one. But before I even do that, I don't even know what the IP address of this machine is. So we're going to issue IPA. This is our network interface card right here, which is ENP1S0. And the IPv4 address is 192.168.122.115 at a /24 network, right? Meaning that we have 255 available IP addresses, but 2 are reserved. Again, if you look back at my network series on being able to configure, labs on Packet Tracer, I talked more on subnetting over there. But for now, let's just focus on this, right? So to also be able to identify the network address of this subnet, you can also issue IP route. And so 192.168.122.1 is going to be our network address. We have our host address here, and then this is the network address. So we're going to scan the entire network, 192.168.122.0/24. Okay. So while we wait for this, well, it already finished. So we're going to scroll up. We see 2 machines here, right? We already know that this is our IP address. And so we have a computer here named John. So we're going to probe that device, 124. We're going to scan for all ports on that machine. And we're going to do a full TCP scan, right? Full TCP scan is going to establish a full connection, be able to do a SYN. We're going to set the SYN, and then the computer is going to respond back with a SYN ACK saying, hey, I got your message, I'm just trying to let you know. And then that's when our machine is going to send them an ACK, right, which is saying, okay, hey, I got your confirmation that you received my message. I'm just letting you know that I received your message, right? So that's a full TCP scan. So we see here that we have an open port, which is SSH on a default port 22. Now, there's 2 ways to identify the service version of that. You can either do scan version and specify the port, which is 22. And it'll let you know right here that the port version is 9.6. And it's running Ubuntu, right? Or you can also issue, there's another tool called Netcat. It's able to being able to listen on a port, right? But we'll do 192.168.122.124. And you specify the port here. And then again, you also get the service version here as well. But for right now, now that I know the IP address of this machine, I also know that SSH is being ran on this machine. Now all we have left is be able to brute force, right? So because for the sake of this lab, I'm running 2 virtual machines, and they're pretty limited on high-end resources, right? So I have 2 files right here. We're going to change our directory to creds. So I'll show you guys over here. So I have 2 files, one being pass.txt and users.txt. If we look into pass.txt, I have a list of possible passwords that we can use to break into this SSH server, and then the same thing as well with users, right? Yep. In a real world scenario, you would definitely want like a large file containing like billions or even like millions of passwords, right? And because I'm running on 16 gigabytes of RAM, it's not a powerhouse being able to actually run through millions of passwords in under a minute, right? But you get the idea, right? In a real world scenario, there are attackers that have, I would say, like GPU farms and just high-end devices with the use of just trying to break into servers and brute forcing machines, right? But anyways, we're going to use a tool called Hydra. Hydra is a tool that brute forces specific services like SSH or even FTP, right? So if when there's a tool, if you don't know how to use it, issue the H flag, which stands for help, and you have additional flags that's here that you can use, right? And you have quick examples on how to use Hydra. But for now, I'm going to use Hydra, and I'm going to set a couple flags. So the first flag being, I'm going to set the F flag, saying we're going to exit when a login and password pair is found. And then after that, we're going to also set the, where is it? It's a large capital, sorry, yeah, it's this one right here. We're gonna set the capital V flag saying, hey, we're gonna, just display the login and password attempts for each attempt, right? So capital V, and then F. Now we're gonna specify, it's gonna be a capital L if you're using a file, or lowercase l if you know the username that SSH server you're trying to break into. So we're gonna use user, capital P, password, 192.168.122.124, and we're going to specify SSH. Okay, so now it's going through both files, being able to identify our credentials, and we found a credential, right? So the credential for this server, the login is Papa John's with the password of 1452387. So we can actually log in SSH Papa John's at 192.168.122.124. Now the password that we found is 1452387. Now as you can see here, we're in as Papa John's at John on a remote SSH server in our network. Now if I go to John right here, right, as an admin, and I list, let's say, any files in here, for example, I have a user called Papa John's. So as you can see here at Papa John's, this directory, you can see we have just folders, right? Now if I were to go and list our current working directory, we're at Papa John's. Now if I want to create a file, let's say touch hello.txt, or if anything, what if I want to write it to that file? We're going to do echo hello there. Okay, so we created a file, and in that file we appended hello there with a smiley face. I go back, let's say, to as an admin at this server, and I list my files. I see that I didn't create a file, right? Somebody did. If I want to see what the content of that file is, I'll do cat hello, and the file is there. Now, potentially, this is a very bad thing because the attacker can either erase your entire root directory or be able to install malicious scripts or even write scripts, right? Like, for example, let's say you have specific security measures in place on your machine where, let's say, you have it where least privileges are in place, where even if attacker were to gain access to or gain a shell into your machine, they are limited in what they can do. Now, again, doesn't mean that they still can't cause damage, because they can. There's always going to be holes in applications, devices, and services, right? Just because humans built these services and machines, there's always going to be some type of flaw, even when an attacker gets very creative on being able to identify those, right? Even if it means they have to write their own bash scripts. Let's say they want, let's say they're very proficient in Python, right? Being able to write their own exploits, but then, hey, they can't install Python, right? Python is not installed on that machine. So now they have bash, because, bash is, it's like, a shell. And so be able to write specific commands and just put that on a bash script and just run that script. It's definitely great danger, right? So again, to harden your SSH server, now I show you guys how vulnerable SSH server is with password-based authentication. The reason why this is pretty bad and it's recommended to actually change to a key-based authentication is because you have bots in the open wild of the internet just scanning for devices, which I will talk more about that on the outro. But for now, let's show you guys how to configure and enable key-based authentication. So let's go as an admin on Lubuntu. I'm going to do clear. Now we're going to change our directory to etc SSH. And if I list any files here, right, we're going to use vim, vim SSH, and we're going to want to do some changes on this SSH configuration file. A few changes, right? First change is we're going to change our default port number. Now, again, changing your default port number, let's go back. Sorry about that. So, as I was saying, changing your default port number, yes, it helps in some way to a certain extent, where, like, let's say you have an attacker that has an automated script that scans for specific ports on devices, right? And one of those specific ports is SSH running on a default port 22, and they have that hard-coded on their script. Now, yes, your that script is not going to look at your SSH port on 1023, right? Because it's not on a default port. Doesn't mean that the attacker can run nmap and just scan for all ports on your machine, and now they identify that 1023 is SSH on your device, right? Again, it kind of mitigates in a way against automated scripts or automated attacks, but at the same time, you're still vulnerable. So we're going to want to disable permit root login. Sorry, let me see. Okay, we're gonna have to exit without saving. Let's go back. We're gonna go back to permit root login, and we're gonna say, hey, we don't want to permit root login, right? So for example, let's say right here, right? Okay. I'm gonna show you root is essentially the highest level of access you can get on a Linux box, right? So for example, let's say Papa John's, right? If I want to conduct such tasks, like for example, let's say I want to read cat Etsy shadow. Now it says permission denied, right? Now, if I actually, with root, I don't need a password, right? Because I'm root, I have the highest privilege on the box. So sudo, and then the password is 1452387. Now I can read our Etsy sorry, not Etsy, shadow. Yeah, Etsy shadow file. Now, the reason why we're saying no is because, for example, like let's say as the attacker right here on the left side, being able to identify Papa John's, still, can you imagine being able to log in as root? Now just straight out of the box logging in, you have the highest privilege, right? So we're gonna say disable root login, and also minimizes the damages that, like, let's say an employee does by accident if they delete a file or whatnot. So then we're going to go to public key authentication. We have to disable that. We're going to say yes, we want public key authentication because this is enabling key-based authentication. And then we're going to say right here, for password authentication, we're going to say no, right? Now, before I even save this file, now let's just say I'm an admin on this machine, right? So even then, we're gonna clear. I have to generate a SSH key for this machine to be able to sign in the SSH server with a private key, right? Because a private key is used to encrypt messages, sorry, not encrypt, decrypt messages, while public key are used to encrypt messages, right? So public key, anybody can see, but private key should stay on your own machine or at a safe place where nobody has access to that private key. Because again, private keys are used to decrypt messages and public keys are used to encrypt. So let's generate our SSH key, SSH key generate. Now, the type we're gonna set is RSA, which is the strongest out of these other options, and with the base of 4096, which is the strongest out of the other ones. So it's generating our RSA key pair, and we're gonna say yes, we wanna save it at home Minecraft.ssh, and if you want, you can set a password. I set a password for an added layer security. Okay, so our SSH key has been generated. If we want to go back to that file, let's go to home, minecraft.ssh, list all files. As you can see here, the ID underscore RSA dot pub is our public key, and the ID RSA is our private key, right? The known host is going to essentially be, you would say, footprints, right? Being able to identify, that way you're able to verify, hey, is this a legitimate footprint that I'm aware of? And if I'm not, then hey, then probably somebody has access to this SSH server. That's a big problem. Now, what we're going to do is we're going to want to copy that public key to our SSH server, right? There's many ways how to do it, but there's an easier way with SSH has a feature, which is SSH ID, copy ID. And we're going to specify the file, which is going to be our public key. And it's going to be Papa John's at 192.168.122.124. Now, remember when I set a password, when I generated my SSH key, I'm going to put that password. Oh, sorry, it's Papa John's password. So let's go back. It's fine, I have it right here. Okay, so we added our key, and now we can now try and log it in to Papa John's again. So now it's asking for that password that's, again, when I created that, generated that SSH key. Okay, now I'm in as Papa John's. Now I can save this configuration file. And after saving this configuration file, restarting my SSH server, or even rebooting my machine, I won't be able to sign in with, I won't no longer need a password, right? So let's do that. Let's escape, WQ, exclamation mark. We're going to save and quit this file. Now, systemctl, restart SSH. That's how you restart an SSH server. But I noticed with this virtual machine, that really doesn't work. What usually works with this virtual machine is just rebooting the entire machine, right? So the connection on this SSH server has been closed because I rebooted the machine. We're just gonna wait until this machine boots up. Right, I'm gonna copy this. I'm gonna need this to do some sudo. Okay, this sudo systemctl status SSH. Okay, it's inactive, so let's bring that up. All right, it's active. Now, let's scan and verify if the port is at a different port number, right? So let's do netcat 192.168.122.124.22. As you can see, there's nothing on port 22. Now if I do 1023, which is our new port, we'll see SSH is on our new port, which is great. So another thing is too, let's go back and do that Hydra attack. If you go here, let's get out of here, home. Okay, you can see here that Hydra is not working because it's saying, hey, connection is refused, but you can always specify the port number on Hydra, right? So let's say the attacker does know the port number, which is 1023 after they did a manual scan. And we do source port 1023. Okay, yep, that was my fault. I did it before the file flag. That's 1023. Okay, and Hydra says it didn't work because it does not support password-based authentication. So that's great. Now we are not able to brute force into this SSH server, and we also have automated, we're protected against automated scripts that are scanning for specifically for default port 22, where SSH is being ran on. Now, if I want to sign in on SSH, right? Let's do Papa John's at 192.168.122.124. We're going to specify the port number, and we're good. Now again, for example, let me create a user, right? So we're going to create a user, sudo add, we're going to say user bill, right? I'm going to show you guys, let's switch to user bill, sudo bill, okay, bash clear. So now we're signed in as user bill, right? Let's say Bill wants to also gain access to that SSH server. We're going to do SSH at Papa John's at 192.168.124. 192.124 port 1023, and we see here that Bill is denied access to the SSH server because you know, we don't have that public key, and Bill is also not in the list of known hosts, right? Which again, even other users who within the same system are also not able to gain access to our SSH server, which is great. Now, that's it for this lab. I'll show you guys how to scan network, being able to identify devices, especially being with ports like SSH, be able to also identify SSH version on that specific device, and then again be able to brute force your way in the SSH service, right? And then once doing so, be able to access the SSH server with the credentials that you gain after cracking from that system. And then after that, I showed you guys how to configure SSH to actually strengthen your security. Sorry about that. By changing your default port number, disabling password authentication, and enabling key-based authentication, right? Just doing those things definitely is going to increase your security. Still not saying that you're fully secure, because you know there's still going to be some gap holes that you also going to need to fix. Like for example, being able to blacklist specific IP addresses if somebody tries to spoof your IP address, or yeah, or also being able to, let's say, add two-factor authentication on your SSH server, because you never know if your attacker also gains access to that trusted SSH client, right? Which is also a big no-no. But yeah, that's it for this lab. Hope you guys learned something valuable from me, and yeah, peace. Have a great day.